are unconnected necessarily from other aspects of body aging, and one of those things is mRNA synthesis. Your body can't really do much of anything if it can't make RNA. You need to make RNA so you can make proteins and do all kinds of other things. And unfortunately, at least if you're a rat, your brain loses about 40% of the RNA content as you go from a young state to an old state. But there's a drug called centrophenoxine, or otherwise called Lucidril, because it makes you lucid. They used it to wake people up after surgery. It was the 5th most popular drug in France for a while. And it completely reverses this age-related change, which is a fundamental core aspect of aging, both in the brain and in the liver. And although the liver doesn't age very much, the Lucidril corrects that. You can still buy centrophenoxine if you look for it. Centrophenoxine also takes care of one of the topics that Maria Trepegis was telling you about, senses intracellular junk. One form of intracellular junk is a pigment called lipofuscin. It builds up in your spinal cord and in your brain. Not good places to have it. But after a short course of centrophenoxine, you can see that the lipofuscin content actually starts to reverse. And if the experiment had continued a little bit longer, perhaps it could have all been removed. We will never know. But this was done in 1974, and of course, since it's so unimportant, nobody cared about it, we haven't done anything since, but we should remember these things because it might be very important. RNA synthesis leads to protein synthesis. So if RNA synthesis goes down, you'd expect protein synthesis to go down. You need to make proteins to have life. And in this one example, rat diaphragm muscle, you lost about 25% of your ability to make protein, but just giving growth hormone to the rats boosted it up to youthful levels after only 8 days. There are other ways of doing this in certain model systems. Centrophenoxine can restore protein synthesis. Acetylcarnitine can do it in mitochondria, and there are other methods. Speaking of mitochondria, we all need mitochondria to make energy. If you don't have energy, you can't really do anything. In studies in which people fed rats acetylcarnitine, which is a common health food nutrient you can buy anywhere, they're completely able to reverse every aspect of mitochondrial aging that they measured, including the synthesis of proteins in the mitochondria, which is very important. Okay, but that's all old stuff. How about the new stuff? So Bill has mentioned all kinds of things to you. I have my favorite 6, so I'm going to talk about those. I'm not going to read the list here because we're going to go through them one by one, but they're organized in order of ease. So the harder ones to do are I'm going to tell you about first, but you're going to like them anyway because they're very, very powerful. And then as we get closer to things that you can do now, then we'll be near the end of the talk. So the idea is to go from the guy on the left to the guy on the right. Okay, so what do I mean by the first thing, which is reversing the developmental aging clock? The concept is based on a technique that recently won Yamanaka the Nobel Prize. And the technique, so as you all understand, we start off as embryos, we go through a series of developmental stages, we end up being old. But you can take one of the old cells and just expose it to Yamanaka factors, abbreviated OSPM, and you can take that old cell back to an embryonic cell. It's not a real embryonic cell, so we call it an induced pluripotent stem cell. And these cells are being developed for therapeutic applications to reverse aging now. But that's not what's really exciting. There's another way that you can use the same basic idea to maybe rejuvenate whole animals, not just one cell. And that is, it was discovered by Ocampo et al. A few years ago that if you cycle the Yamanaka factors on and off so that they're not on all the time, you don't have to take that old cell all the way back